About linear equations in one variable. But first, let's try to compare and contrast the things and expressions that you can see on your screen. All right? So by now, you may have already realized that those on the left side are expressions that are considered as algebraic expressions. And if you're going to review, when you say algebraic expressions, these are combinations of your numerical, arithmetic, and also your literal or your alphabet, which are, of course, separated by your addition and subtraction signs. On the right side, the difference, if you may have noticed, is that there is an equal sign. Now, the presence of the equal sign makes it an equation. And why is it called linear equation in one variable? These are some of the terms that we're going to define today. Let's begin with an equation. An equation is a mathematical statement that shows two expressions are equal. Let's take the example of first one, 2x minus 1 equals 5. You will notice that if we're talking about an equation, there are two sides of the equation. You have the left side, which is located on the left side of the equal sign, and the right side, which is located, of course, on the right side of the equal sign. Now, the equal sign says that these two expressions here are equal. It's like saying that 2x minus 1 should be equal to 5. The same is true with y squared plus 6, which should be equal to 12. And 2 multiplied to the quantity of m raised to the power of 3 minus 5 should be equal to 10. That is an equation. But when you talk about linear equation, it is an equation of the first degree. Now, what does it mean if it's an equation in the first degree? It means that the highest exponent of the variable is 1. Let's try to check the example. 5a plus 2 equals 3. The variable here is a. As you can see, there's no exponent written. But what did we learn about this previously? That if there's no exponent written, that is already understood to be 1. So this is a linear equation. The same is true with the second example. You have 2x plus y equals 0. The variables are x and y. And there's no exponent written on the variables x and y, which means that it's understood to be 1. Another example here is 2 times the quantity of z minus 1 plus 4y equals 9, and it follows the same definition. So we're done when we say equation and linear equation. Now, what is a linear equation in one variable? It's an equation in which there's only one variable present and there's only one solution. When you say solution, it's also synonymous when you say root or answer of the equation. Now, I'll explain that further. Let's say I have 4x minus 2 equals 8. It's a linear equation in one variable because, first, there's only one variable that we can see, and that is x. And the exponent is 1, which makes it a linear equation. Now, what value should we replace x so that if it's multiplied to 4 and subtracted by 2, which is equal to 8? If you're going to think it further, it's going to be just one number. And the answer to that, or the process of finding the answer to that, will be in our next discussions. The same is true with 2 times quantity m plus 4 equals m. There's only one number. There's only one solution. there's only one root or answer that will satisfy the equation. Now, what do I mean when I say satisfy the equation? It means that if I check or substitute the value, it will make the left side of the equation equal to the right side of the equation. So that is the first set of our definition when we talk about equation, linear equation, and linear equation in one variable. Let's try to put it into practice. Let's first have basic examples of translation. If you want to solve equations, you need to know how to translate equations from verbal sentences into numerical or symbolic. Now, let's have, for example, twice the difference of a certain number and 8 is 16. We've learned this before when we had our discussion about algebraic expressions, when we learned how to translate verbal algebraic expressions to symbolic or to symbols. So, let's first identify what is the unknown here in our problem. It says twice the difference of a certain number and 8 is 16. We know that the unknown is the number. We don't know what that number is. So first step is to let x or any letter to be our variable. The next step is to find the equation that will involve this variable. So it says twice the difference of a certain number and 8. So if we're going to translate that into an equation, that becomes twice, as you can see here, this is now the certain number, and the operation that we're using is different. So difference of a certain number and 8, and twice of that is 16. So that is your equation. And from here, this is very important because we cannot solve this accurately if we cannot find the correct equation. Let's try another example. 4 more than thrice a number gives a result of 52. So again, let's try to check and verify if there is an unknown in the problem. It says 4 more than thrice a number. As what you can see, x is the number, or we don't know what that number is, so we will let that as x. Now we are ready to find the equation once we have our variable. It says 4 more than thrice the number. So you can see here, thrice of that number, 4 more, is 52, or gives a result of 52. Let's try some more. The quotient of a certain number and 10 increased by 2 is 36. So again, we let x be our unknown number. So by now, I think you know what to do for the first step. You have to always represent that unknown number as a variable, okay, using any letter. And then we find the equation. The equation says the quotient of a certain number and 10. So you have their x divided by 10 or over 10, increased by 2. So you have plus 2 is equal to 36. Last one. Let's try. The sum of 3 consecutive positive integers is 45. Now, when we talk about consecutive numbers, it could mean that the next number is higher than the other. Now, depending on the condition, then we will know how to represent that. So when you represent consecutive positive integers, always the first number is represented by the single variable. And the next number, if it's just consecutive positive integers, it means that the next number is 1 more than the other. It means it's going to be x plus 1. And the third one is x plus 2. So our equation would be, let's go back first to the problem, the sum of the 3 consecutive positive integers. So we're going to add them. So you have the first one added to the second one, added to the third one, is 45. Now take note that consecutive numbers increase by 1, in which the first number is represented by the variable x. That's it for now. I hope you've learned something from this very short discussion. Your task is linked below this discussion. Hope that you will do the task and learn more. Thank you very much.